This video is over section 6.4, Algebra of Functions and Function Composition. A lot of letters right here, but it's really pretty basic. It says given functions f and g, the functions f plus g, f minus g, f times g, and f over g are defined by f plus g of x is just f of x plus g of x. F minus g of x is just f of x minus g of x. F times g of x is equal to f of x times g of x. And then f over g of x is equal to f of x over g of x. And then we just need to make sure that g of x is not equal to 0. The domains of the functions f plus g, f minus g, f times g, and f over g are all real numbers in the intersection. So we need them to be in both of the domains of the individual functions f and g. For f over g, we further restrict the domain to exclude the values of f for which g of x is equal to 0. Okay, this first box says for the following, evaluate the functions for the given value of x. So we have f minus g of 3. So what this means is f of 3 minus g of 3. And we are given our functions in this table here. So f of 3 would be negative 3 times 3. And then minus g of 3 would be the absolute value of 3 minus 3. When I simplify this, I get negative 9 minus the absolute value of 0. So this would just be negative 9. Okay. F times g of 2 would just be f of 2 times g of 2. So f of 2 would just be negative 3 times 2 times g of 2 would be the absolute value of 2 minus 3. And then I'm going to simplify this, and I get negative 6 times the absolute value of negative 1, which is equal to negative 6 times just 1, or negative 6. Okay, this last one, h over g of 3, is equal to h of 3 over g of 3. And when I do that, h of 3 would be 1 over 3 plus 2, all over, and then g of 3 would be the absolute value of 3 minus 3. And when we try to reduce this, we're going to have 1/5 all over the absolute value of 0, and that's going to be 1/5 over 0, which you can't divide by 0. So this one would have no solution. And that's in parentheses, it'll say can't divide by 0. Okay. For the following, refer to functions r, p, and q. So that would be these functions here. And find the indicated function and write the domain and interval notation. So for r minus p of x, we're going to take r of x minus p of x. Okay, and r of x for this is 2 of x minus p of x would be x squared minus 4x. When we simplify that, that would just be negative x squared minus 2x. Okay, and the domain for this one is going to be all real numbers because well, I guess let's go up here. The domain for r would just be all real numbers because it's a linear function. The domain for p of x would also be all real numbers because it's a quadratic function. Q of x is a little different, so let me take this one down here, I guess, before we start. We want, because there's a radical under here, we need like everything under here to be greater than 0 because you can't have a negative number under the radical if it's a function. And so if I square both sides, this would be 2 minus x is greater than 0 squared is just 0. So I have negative x has to be greater than negative 2. X has to be less than 2 for this one to be work. So for here, the domain is x less than 2. Okay, so back to the middle, we have p of x times q of x. So this would just be p of x times q of x. And when I do that, I'm going to have x squared minus 4x for p of x times, and then q of x is just the square root of 2 minus x. Our domain would be the intersection of, so I guess let me write that. The intersection of the two domains, so that would be the intersection of all real numbers and the set x is less than 2. And so the intersection would just be this x is less than 2. Sorry, I wrote so sloppy. So the domain for this one would be x such that x is less than 2. And if we wanted to write it in interval notation, I guess, yeah, I did say. So the domain best would be negative infinity up until 2, not included. Because if we plug in, well, I guess if we would include it, because if we plug in a 2 here, we'd have a 0, which is fine. So we will include the 2. So I need to go back here and say, okay, greater than or equal to 0, greater than or equal to 0, greater than or equal to 0, which makes this less than or equal to 0, less than or equal, or sorry, less than or equal to 2, less than or equal to 2 there. So right there, I adjusted. All right, last one, we have q over r of x, which is just the same thing as q of x over r of x. And when I plug that in, I'm going to have the square root of 2 minus x all over just 2x. When I consider the domain, r of x is all real numbers for the domain. For q, we need our domain to be less than or equal to 2. So the intersection is just going to be this less than or equal to 2. So the domain was going to be negative infinity to 2. However, we do not want a 0 in the denominator here. And so we also need to include, we can't have 0. So how you write that, I'm not sure how it'll be online. Let me know if you come across a problem. But this backslash means not including, and then we would just put 0. So if I plug in a 0 there, well, I would get a 0 in the denominator. So the domain for this last one would be negative infinity to 2 inclusive. However, we cannot have a 0 here, or that would mess up our fraction. That was a lot. Let me know if you have any questions on that, or if I missed something or rushed or whatever. All right, this next section is the composition of functions. It says the composition of f and g, denoted by f of g, is defined by f of g of x. So this is kind of like, I'll write that. It's like of equals f of g of x. So it's kind of like you put g inside of f. Okay. The domain of f of g of x is a set of numbers x in the domain of g, such that g of x is in the domain of f. So it's a little confusing, but once we do a couple examples, I think it'll click. So for the following, refer to the functions f, g, and h. Evaluate the functions for the given values of x. So f of g of 8. So we need to find g of 8 first. So f of, and then I'm going to do 8 cubed minus f times 3. And when I do that, that's going to be f of, and I'm just going to plug all of that in my calculator. I don't want to mess up by doing something by hand. So when I do 8 cubed minus 5 times 3, all in my calculator, I get 497. And that was g of 8 was this that I plugged in my calculator, which is 497. And now I plug in that into f. So when I plug that into f, I'm going to do the square root of 3 times 497. Okay, so all those highlighted in pink are g of 8. So I took my g of 8 and plugged it all the way through. So 3 times 497 is the square root of 1491. I don't know that that simplifies. I don't think it does. I'll leave a comment if I find something, but I think that would probably just be the final answer. All right, middle one, h of g of 2. I'll use a different color just so we don't get confused, but we're going to find g of 2 first and then plug that into h. So that would be h of g of 2. We're going to be doing 2 cubed minus 5 times 2. And again, I'm going to use my calculator for that. That green highlight is just g of 2. I don't want to mess up, so I'm going to use my calculator. 2 cubed minus 5 times 2 is negative 2. All makes sense. 8 minus 10. And then now, so all those green highlights that you see, those are all g of 2. And so we're going to plug g of 2 into h. So when I do that, I'm going to have negative 2 plus 6. So I just replaced that x with g of 2, which was negative 2. All right, and when I simplify, I'm going to have 2 plus 6, and all of that is just equal to 8. All right, last one, we are trying to find f of h of negative 1, so I'm going to start with that h of negative 1. So I'm going to have f of negative 1 plus 6. Again, I am just plugging in negative 1 for h, and then I'll plug that into f after. So that's going to be f of 7. This becomes positive 1 plus 6. And then when I plug in 7 for f, that is going to be the square root of 3 times 7, or just the square root of 21, and that does not reduce. All right, for the following, refer to the functions m, n, p, q, and r. Find the indicated function and write the domain and interval notation. So back up here, we need to note that the domain of the composition is a set of real numbers x in the domain of g, so that's the inside one, such that g of x is in the domain of f. So it's kind of like intersection, but we got to look at the g first. Okay, so the first one we have n of p of x, so that would be n of p of x, or that would be n of x squared plus 5x, because that's p, okay? And when I plug that into n, I'm going to take p and put it for the x. Okay, so what that looks like is I'm going to have x squared plus 5x, and then plus 6. So I'll use my highlighter to show you a little bit better, but I took p of x, which is this right here, and I plugged it in where the x is on n. So instead of this x right here, oops, I didn't mean to grab a highlighter. Instead of this x right here, I plugged in p of x instead. Okay, when I simplify that, that's just going to be x squared plus 5x plus 6. When we look at the domain of p of x, this is just going to be all real numbers. It's a quadratic. Okay, the domain of n of x is also all real numbers. It's linear. So luckily, the domain of this one is just all real numbers. I'm not sure how the computer takes the answers. You might have to write it out. But yeah, any number that's real will work for that one. All right, m of q of x. We're going to have m of q of x. I write my q's like that so they don't look like 9s. Okay, when I look at the q of x, it's right here. Let's use a color. I can use green. I'm going to plug in q of x into m. And m, my x is inside that square root, so I'm going to take that and plug it in there. When I do that, I'm going to have the square root of 1 over x minus 4 minus 3. This looks so strange. Honestly, I would probably leave it like this. You can combine these two. It's going to look kind of funny. If the computer makes you do that, I will be shocked. At the end of the video, I'll do it just to save time. I'm going to skip it for now. Okay, but when we look at the domain of this one, first of all, the domain of q, x can't be 4, or that would give us a 0 on the denominator. And then for m, we need to make sure that x minus 3 is greater than or equal to 0. For m, we need x minus 3 is greater than or equal to 0. We don't want to have a 0 in that square root. Okay, so if I add 3, we need x to be greater than or equal to 3. So that's the domain for m. X is greater than or equal to 3. Okay, so when I consider the domain of m of q of x, x can't be 4, and x has to be greater than or equal to 3. So we'll just do 3 to infinity, and then backsplash or delete that 4. All right, for the last one, r of n of x, so we're going to have r, and we're going to put n of x inside of it. Okay, r would be the absolute value of 3 times x plus 2, And instead of putting x, we're going to put in, which is x plus 6. Okay, when I simplify that, that's going to be the absolute value of 3x plus 18 plus 2. And when I simplify that, that's going to be the absolute value of 3x plus 20. Okay, n of x, we already said that the domain for that one is all real numbers. R of x is an absolute value function, and our output or our range will always be positive, but as far as inputs, we can put anything into x. This one is also all real numbers. So for this one, the domain would be all real numbers. All right, you can stop the video here. I'm going to go ahead and combine these two just for the sake of the video. I don't think that your homework will ask you to do this, but let's just do it just to be safe. So if I needed to combine 1 over x minus 4 minus 3, I need to have x minus 4 in the denominator on this one. So I'm going to multiply by x minus 4 times x minus 4. We already are assuming that x can't be 4, so we don't get a 0 there. So this is going to be 1 minus 3 times x minus 4. And now they both have x minus 4s in the denominator, so we can write it like that. If I simplify the top, 1 minus 3x plus 12 on the top, or numerator, x minus 4 in the denominator. And so if I were to write it combined to be negative 3x plus 13 all over x minus 4, and that had a square root on it. So if you wanted to simplify it, that's how you would do it. I went fast, but I really don't think they're going to ask you to do that. So.